when we have talked about the electroscope, I think it will be a good idea to discuss about charging and discharging. Now, whenever we are providing some charge to an object, we call that as charging. That means, let's suppose that an object is neutral. That is, it had equal amount of positive charged particles and negative charged particles. Now, if we provide some excess of charge, that means we are charging the body. And just the reverse process is discharging. That means you are removing the charge from a body. So, charges is providing a charge to an object by various means like friction, conduction, etc. We have saw that we can charge an object by friction, that is by rubbing. So when we are rubbing two objects, we're basically creating friction. Now, how can we charge an object by conduction? Conduction means with the help of conducting material. Like here in this case, the aluminum strips are not charged, but it is connecting through a conducting material, which is a paper clip. Now, as soon as you bring this riffle, that is a charged particle, in contact, so this riffle will conduct the charge. That is how these two aluminum foils also get charged. This is the process of charging, right? So in electroscope, at this step, aluminum foils get charged, and when aluminum foils get charged, what happens? Since both of them will occur like charges, so they tend to move away from each other. They will repel each other. Now, what is discharging? See, right now, these aluminum foils, they have same additional charges. That means if the object is positively charged, these aluminum foils will also have the positively charged, right? In this case, so material is positively charged, so that is why these foils are also having positive charge. Now, discharging is that process in which we take away the extra positive charge from these aluminum strips. Now, what is discharging? It's the removal of charge from a charged object. Now, once these objects are charged, they occur charge. Now, how do you remove the charge from them? So, let's take an example to understand this. Now, suppose instead of this charged object, let's touch the wire with your finger. Then what happens? See, finger actually provides a path for these excess of charges to get grounded. So the foil strips will lose the extra charge to the earth through our body, through our hand. So this process is called discharging. So discharging is nothing but the removal of excess of charge from an object. Discharging is also known as earthing, okay? Or you can say grounding. So discharging means taking away the excess charge from an object. So whenever we tend to touch any object with our skin, now see, our body acts as a good conductor. So therefore what happens? The excess of charge present in the aluminum strips or present there, they get grounded or they reach to the ground through our body, because our body is a conductor. So that is why earthing happens, and the object again, after losing the charge, it will become neutral. Now, once these aluminum foils get discharged, what happens? They again come together. First, they repelled because of the charge, but when they lose all the charge, when discharging happens, they do not repel away from each other. Now, let's talk about earthing. Earthing has a very important role to play in our day-to-day life. Do you know how? See, all of us have a lot of electrical appliances in our house. We have fans, tube lights, we have televisions, washing machines, so many appliances, and they all are dependent on the electric circuits. So whenever you have a complete circuit, only then a bulb glows, only then your fan starts. So everywhere the electric circuit plays a very important role, right? Now, when you look at the electric circuits, a lot of wires are involved. So when you have so many wires involved, that means so much of current is flowing through each of those wires. So taking a safety measure is very, very important, because when you actually look at the main line from where the current is flowing to your house, there is chance of that sometimes you might have voltage fluctuations, or though and those voltage fluctuations can actually damage sometimes the electrical appliances. In fact, the chance of electric shock is also more. So when you have that much of current flowing throughout your house, so that is where earthing acts as a safety measure. So we'll see what exactly happens in earthing and what it does, that it acts as a safety measure. So earthing is also termed as grounding, and it's nothing but the process of sharing charge with the earth. See the word literally, this earthing, what does that mean? It means sending the excess of charge to earth. So you can very easily remember earthing. The word earthing is derived from earth. Why? Because all the extra charge are being sent to the earth. So let's suppose you have a neutral object, and if you touch that neutral object, there's no risk because there's no charge. But if that object has some charge, so as soon as you touch it, what happens? A current tends to flow because the excess charge want to flow. They want to go to the ground. Now, as soon as current flows, you feel electric shock, right? So, in earthing, what happens is the circuit is prepared in such a way that we provide a path for grounding. We provide a path through which all the excess of charge can actually go to the earth. So, therefore, you are not left with excess of charges, right? So, you do not feel the static electricity. So, whenever you touch a plug point or a wire, uh, because all the excess charges are being earth, so you do not feel any static electricity. Now let me give you a common example. See, all of you are aware, you would have seen the 3-pin plug which are using in most of the appliances, right? Now why 3-pin plug? Because these are safer than 2-pin plugs. So let me first explain what are 3 pins here. What are these 3 pins for? See, you have a socket for these 3 pins, right? Where you actually insert this 3-pin plug. Now, these 3 pins are connected to the 3 kinds of wires. One of them is connected to the positive terminal, this and the other one is connected to the negative terminal. And this third one, it is for earthing. So, let's first talk about earthing. Now, inside our house, you would have seen these kind of sockets, right? So, this particular terminal, this is always for grounding. Now, what does it do? It just take all the charges, all the excess charges, and it through this wire, it will directly take it to the ground, so that no excess charges are left here. So when you do not have any charge accumulation in the socket, then the chances of electric shock reduces to a large extent. Sometimes you have voltage fluctuations. Then also all excess charge can immediately be grounded through this wire. So the chances of damaging the appliances also decreases. Now what about the other 2 pins? These 2 pins are for different kinds of wires to which they are connected, and these are actually connected to the main poles from where electricity is coming to your house. So basically, these 3 wires which you have are live wire, neutral wire, and the earthing wire. One of them is positive, live wire, that is positive, and the other one is neutral, that is a negative one, and the third one, earthing, is for actually this is meant for grounding purposes, earthing purposes, this wire, right? And this earthing removes the excess charges. So sharing charges with the earth is called earthing. So whenever you are using 2-pin plug, now what happens in 2-pin plug? You need only, there you are having only 2 pins, right? You need the positive terminal there and the negative terminal, because without that, current will not be able to flow. So you are having there only live wires and neutral wires in 2-pin plugs. Then what is missing? earthing is missing. So the risk is more in the 2-pin plug. Therefore, it's always advisable to use 3-pin plug and do not use a 2-pin plug. So this is how earthing acts as a safety measure for the electric circuits and appliances used in our house.